Hello everyone. So today we are going to solve this problem from 11th of August. This GeeksforGeeks problem of the day, that is largest odd squares with limited ones. So what is the problem is saying is we have given a 2D matrix that is of size n cross m, and then m can be both are unequals or both can be equals. So they can contain any values, and we have to find out the odd size square. Odd size square means the length of the square will be should be odd, and we have to find the that square so that it can have number of ones, like that can be at most one, at most k ones. So basically if that odd matrix, odd square, we can say from this particular matrix, if I have five ones and we require the k is equals to 9, so we can get this answer because we have to find the at most k ones. Okay, we can take this problem like how we are going to solve this. We will go with this board, so we will see quickly how we can solve this to increase this size. Okay, we can okay, let's draw first the matrix is how it will look like quickly. 1 0 1 0, and this is 0 again, this is 1 0 1 1 1. There are multiple points in this to understand what is the minimal requirement or prerequisite for this problem, but I will try my best to explain from the beginning level. So this we have the given the input matrix, and we have the given the center as the 1 comma 2. So there can be q queries, and queries can be like anything we have given as a 1 comma 2 and k equals to 9. So this is center. So basically if indices y 0 1 2, so we have given the center as this one. So this is the center for us. So considering and how we are going to find the square matrix from this center. So taking this center, we are going with the all the four directions, and we will check what are the. So basically, if we will go in the like one direction, like let's suppose with side length of one, so we will find out this matrix particularly. So this will be the subset. This is the odd square, square of length of three, and this is the odd square length. And we can see like 1, 2, 3, 4, 5, 6. So we have total six ones, but as we have to require nine ones. So this can be a possible answer. And we can go further also. Like this is the we only like went only one side. If we go into like twice, so we will see, but there is like we will go out of the bound of the matrix. So we will not go into this. Consider we have a like further like values like 0 1 2 something. This is a matrix. So now in this case we can go further also, like in that case this complete matrix we can we need to consider, and how many ones are there. If those ones are less than equal to k, then we can take this as the answer. We have to find the longest odd side square length. And the one important point to think about is like every length that we are going like one, or we are going twice, or we are going thrice. Every time the length of the square will be the odd. There cannot be a possible solution. The length of the square is even. So this problem can be reduced to like a longest square with limited ones, but odd is just to give you like maybe hint. So odd will be the length. Why I'm saying is like let's suppose if I'm going to one path, only one length. So where what I'm doing is I am taking one more from up and one from down, and one is the horizontal one. So every time if I'm saying like if I'm going s length, so basically 2 star s I am doing, and I am incrementing the horizontal length by one. So this number will always be odd. So every time this length will be the odd. There will not be any condition. So you will get an even length. First thing is that one. Second thing is how we will solve this problem. So coming to this part, okay, taking this as center, what we need is we need the longest length, longest square. We need to find out how we can find out longest square. So considering we have this coordinate scale, and this is I comma j. Maybe I'm not able to write properly, but see like in four directions, what can be the possible coordinates. So this will be of course I comma j plus 1. And what about this one? So I will take this. What about this one? This will be the like I minus 1 j. And what about this one? So this will be I comma j plus 1. And for this one, this will be my I comma j minus 1. So if I'm going 1 1 length, it will give me 1 1 side length. So it will give me I comma j minus 1. If I'm going like let's suppose any length like s. So it will give me I comma j minus s, I minus s comma j, something like that. We can get those coordinates. What I mean to say is here is like anytime if you will go to these square matrix, we need to identify, okay, where is the bounded matrix is and what are the possible coordinates that we are going into are four of the centers. Like let's suppose this is the center. So what are these four coordinates of this square? This is the this square we can get. This is the this coordinates. This we can get these coordinates, right? And we need to find identify, okay, these coordinates are valid or not valid. I mean to say is, are these in the matrix length or not? If they are, then we need to find out what are the possible ones they are considering it, and we need to check it. So this is the brute force solution. This first step is just to for each of the center, you need to identify what are the four coordinates, and for each of the four coordinates, you have to identify number of the ones, and if those are less than or equal to k, you can consider this. And if those are less than or equal to k, of course you need to again go further. Like now we are taking as a one of the length. Now you have to take as a two of the length, and if that are also bounded, then you need to identify the same pattern. You have to go further. For all of the Q queries, you have to do this. So this will increase your time complexity of the program, of course, because for every query you are finding like in each and every length you are going and you are checking that. So how we can optimize this? So optimize this, what we need is we require like for like consider this is a matrix for center 1 comma 2. We need to identify how many ones this particular matrix is considering. Let's suppose somehow we are able to find out this particular corner of the matrix, like this particular thing, we have the sum. Consider this particular corner, we have the sum of the ones, like how many ones are there in this particular corner. So if we deduct from that particular corner, like this complete matrix, if we deduct this particular sum, number of the ones that are coming into this, number of ones that are coming into this side or this side, and we are we are like subtracting this both twice. So if we are adding this again, so it means we can cover up this matrix only. How we are going to find out? Let's suppose consider that example, how we are going to solve this. So for that, uh, okay, let me take this same example again. Uh, how we are going to take this. Okay, so we have this input matrix that is 1 0 1 0 0. Basically we have to find out the bounded matrix sums, number of ones. If we get that, it will be very easy to solve that, like how we are going to see that. And we have these five ones and 1 0 0 1 0. So consider like we need to, as we discussed, we need to find out the like number of the consider we have this example also 0 1 2. So it will be more easy to understand how we are going to handle this more. So we have to find out, like let's suppose this is the center and we have to find out what are the length. So let's suppose if I'm doing the like row sum, because we need to find out the number of the ones that are coming into this row wise, horizontal wise, and then we can need to find out how many are the ones in the vertical wise. So first we need to row wise. So row wise we can say this one is one, so zero is there, so there is no increment in the one, so number of the ones still remains same. But here it is one, so it will become as two because number of one incremented. But here it is zero, so we can say this is two. Sorry, I forgot this row. So this is our first row, zero, one, and two is there, but there is no one, so the number of ones are one. So what is it saying is this is row matrix. So what it is saying is if you are came to this point, this is 1 comma 4. If you came to this, how many number of ones are in the horizontal matrix? So row comma 4 is the two number of the ones. So this is saying there are number of the two. We don't need to iterate every time. We can just say the value of this it is saying the horizontal ones. So similarly, we can quickly this one, one, two, and this three, and this four, and this one, two, three, four, five, and sorry, one, one, two, so two. So this we are find out horizontal basis. Now we need to find out the column wise, because for this, as we discussed, for the corner of the matrix, we need to find out how many rows have how many total ones are in the rows and total columns, so that we need to figure out the total number of ones. This is what it's saying is 1, 2, 3. So this is 3. So there are total number of ones in 3, but we don't know in the column vertical also how many ones are there. So for to do that, we will do the column wise also. So for first row, the value will be the same because there is no. And for the next row, what we will do is, so we will take this like these are the vertical sum. So basically we can say these are the sum till now here. And if we are incrementing this value by this, so we will get this values. So 0, 1. So basically 1, 2, this is 3, this is 4, sorry, this is 3, and this is 3. How I'm getting this? Maybe you understood like because this is the vertical sum till here, and I am incrementing this value, so this will become as 3. What this value is indicating? So this is indicating is like for the second row and last column is how many number of the ones total are there in this. Like you can say 1, 2, and 3. So there are total 3 ones in there till in this matrix like this for every of the vertices. Considering this 2, quickly we can fill this 3 and this 5 and 6 and 7. For next row is 3, 5 and 5 plus 3 is 8, 6 plus 4 is 10, this is 12, this is 4, this is 6, this is 9, this is 12, and this is 14. So what it is saying is last column number is all the number of ones are there in the in this value is 12, 14, sorry. So how like this we can identify the column matrix, this row matrix sum, prefix sums, and we will use now this column matrix to identify quickly the number of the queries. So consider we have a query like let's suppose this 5. This is the center and you need to identify. So what we will do is like consider this index of this is 2 comma 2. So as a general notation, how from where we will start? As we discussed, like there can be 2 comma s plus 1. We will have a length of the square. We will 2 comma s. But what will be the value of the s? So s can be starting from the 0, 1, 2, 3, 4, 5. Anything s can be possible, right? From but where from we will start it? So S can be maximum at like 2, right? Because if S I will take as 3, there is no point of 2 taking as the 3 because I will go out of the bound. If I am adding S here in this 2 plus 3 is 5, that I am out of bound. So what I will take is minimum of the center that we have given, minimum of the center that we will start from S and we will check. Okay, we will decreasing the S one by one and we will check where it will going to be the answer of the value. So what I mean to say is here center is 2 comma 2. So S will become my 2 and I will start with considering where it will going to be lie. So 2 comma 2 means I am covering all of the matrix like this complete matrix. How we will identify the complete matrix? This is 2 comma 2 as we discussed in the coordinate scale. This is I comma j that we have that is center, and we can identify all of the 4 coordinates of the square and we will figure it out. It is we will see this is center. I will show you in the code also how we will identify. So we will check, okay, this is the 14 that we are going to cover, and how many are the values that we have in the further that we need to decrease, because in this case we don't need to decrease because this is the center and 2 is the length. So we are going to cover up the complete matrix and we are going to check. There is another way also, now we are taking as s equals to 2. Now then again you will decrease s by 1. If the answer is not there as s equals to 2, then you are going to check with s equals to 1, and then you are going to check s equals to 0. So now we are decreasing this value by 1. And we can do here binary search also. Let's suppose the maximum length of the square we need to find out with the range of the s is becomes like 0 to minimum of the center of the coordinates. So 0 to 2, we can get the scale and we can find out the mid and we will check that values. But I wrote this code, or I already wrote the code for this, so to save our time, and basis on the s decrementing by 1. But you can try out also the binary search code also for that. So seeing like how this is doing. So first I'm preparing the row matrix, how it will look like as we discussed. Row matrix is just simply horizontal sums of the number of ones that we are encountering. So if we are in the first column, so there will be no previous columns, right? So what we are just taking it as a 1, or otherwise we are going to take it as 0. And if we are in the sum of the columns and we are encountered as 1, so what I will do is I will take as a previous sum and I will increment the 1, or otherwise I will take it as a directly. Now going to prepare the column matrix from this particular row matrix only, because now we are only get the horizontal sums. Now we need the vertical sums also. So for vertical sums, what I'm checking is if I am in the first row, so it means I don't need to do anything. I just directly take it as the first row values because there is no previous rows. But if I am in the middle of the some rows, so what I will take it, I will take the vertical sum till the last row that I've encountered, and I will take the current row value of that particular, so that I will get the similarly like here I will did the dry run. So similarly you can get that. And then I'm again only like going through the queries and taking this as a center RC and CC, and I'm checking the side length and I'm just adding into the side length into my answer and returning my list. But what is this sideline? This is the important algorithm that we are going to do is, so as I mentioned, I am going to take the minimum value of the centers. Why I'm taking the minimum value? To bound the like where S can be reached, because S can be reached anywhere, right? So we have to bound right, or otherwise you can do like S0, S1, S2, S3, and if it is out of the bound matrix, then you have to stop there. This is one of the way, but I'm checking the to not going into that manner, like I'm bounded by S, so that minimum value. And first I'm doing the like iteration one by one. I'm first checking like is this like RC plus S and CC plus S. So is these are the coordinates are the valid or not? If these are not valid, there is no simply nothing to means like this. What is this value means? Like RC and CC is the center of this coordinate, and S I'm taking as like let's suppose 3. So there is no point of to going into the further, because 2 plus 3 is 5. 5 it is out of the boundaries directly. So there is no point of to go the further, and we will I'm just taking this as an extra check, and then I'm going to do as a decreasing value, because why that I've showed you, right? So let's suppose consider we have a this particular consider this we have this center, and we are going to take the S equals to 1. So the length, consider this we have the, and length will be the 1, so this will be the matrix. How we are going, now we have the sum of these values, right, in the column matrix. If this is the center, we are going to consider this is the matrix. So we have the sum complete till this there. This is also included, this complete is included, but we have to deduct this sum, right? We are not going to include this sum. So for to deduct this sum, I'm checking these coordinates. And how we get these coordinates? These are simples. If you know the center coordinates and if you know the length S, so you we can find easily these four coordinates as I mentioned in the coordinate scale. And basis on these four coordinates, I'm checking this. This is just like this coordinate minus column minus one, row will be the same. And for this row minus one will row will be decremented and column will be the same. And I'm decrementing this both, and I'm going to add this value because this we are subtracting twice. So now I'm going to add this value from this coordinate with the help of this coordinate. So similarly, I did this. This is the subtract one that we are going to do is I'm checking this is first thing is it valid or not. If it is valid, then I'm deducting this value. If it is not valid, then I'm just taking at the 0. We don't need to subtract anything. This will be the case arise when you are taking this as the center and your whole matrix will be the bounded matrix. So for this value, you are mainly focusing on this value and you don't have to deduct any values. Considering for the sub 2, this is for the vertical side, and for the addition one, this I am adding because we have subtracted twice, so we are now adding it. And I'm checking the number of ones. So this will simply tell us like these are the number of ones for these values. And first we will get those. We will just checking if the number of ones are less than or equal to k, because we need the at most ones, at most k ones. If I get it, I will just taking returning the side length into 2 plus 1. And if I didn't get anything from s to 0, then I'm just returning minus 1. So here you can, for optimization this, you can also apply the binary search between min and 0, and you can quickly search about this. But I did like this. But this you can take as a homework. If you have any doubt in that, you can comment it. I will try to include that also in my video. And I'm just adding into my sideline. I'm returning this sideline array list. So this I wrote in the Java program, but the intuition is the same. You can take the approach and you can write it in your program that you are comfortable with. Coming to the time and space complexities. So as you can say, we are taking as the n cross m space. We are taking as the extra space that to storing these variables. And this will take as a big of n cross m time. First take like time complexity. So this will take big of n cross m, and this again big of n cross m. And here we are doing the queue queries. So this will be the length of the queue, and get side length will work for the minimum. and minimum will be this center coordinates. So that can be maximum, like you can go to like every query is like n minus 1, m minus 1, considering this is the center in the worst case. So the time complexity for this will be like but, it is big of n cross m, and we are doing again big of n cross m, and what we are doing is big of q star. Q means this length of the queries, and we are doing the side length. Side length will be the like minimum. So this we can consider as minimum can be like your n minus 1 or m minus 1 that we are considering. So this will be the minimum of input matrix length, that can be n comma m. So this is the time complexity of the current program. And for the space complexity is we are taking the extra space. And other than the input matrix, we are not taking any extra space. So this is clearly big of n star m. And to optimize this, like we are now taking n cross m of the minimum. To optimize this, we can use binary search to then in that case, the complexity will be reduced to log of minimum of n comma m. So in the worst case, I think this is the one. And if you like, we can try to submit this program. Think it will, yeah. So you can try to run this program. If you face any issues, please let me know. And if you like or learn something new, please like and subscribe my channel. Thank you, everyone.